In our last class, we studied about wave theory, where light is considered to move as waves, and we learned about 3 different types of wave fronts. Now today we are going to derive Snell's law using wave theory, or specifically the Huygens principle which we studied in our last class. To derive Snell's law, let us consider two medium, air and water. Okay, this is the surface of separation between the two media, air and water. We know that air is less dense, water is denser than air. Consider a plane wave front. Okay, coming like this. This is a plane wave front falling on the surface of separation between this air and water interface. This plane wave front, see, this is a plane wave front. It's coming towards the surface of separation. Let P dash be the surface of separation of these two media, air and water, and let AB represent the plane wave front. Okay. Now the point A of the wave front has touched PP dash, the surface of separation between the two media, and let I be the angle of incidence. I told you this light wave is moving from a rarer medium to a denser medium. Okay, so what happens? It bends towards the normal. The dotted line represents the normal. It bends towards the normal, and let R be the angle of refraction. Okay, so if this angle is I can say that this angle is also I. Why? This is the normal, and this angle is also 90 degree. Because this is a plane wave front, I have completed this. This angle is 90 degree. This angle is 90 degree. And since this angle is I, this angle is also I. How do you get that? From this figure, it is simple geometry. Since this angle is I, this angle is also 90 degree. This angle is also 90 degree. So since this is I, this is also I. Let V1 be the speed of light in the first medium, air, and V2 be the speed of light in the second medium, the denser medium. You can see that the light wave has reached the point A, but the other side of the wavefront B has not reached this surface of separation PP dash. Okay, let this wavefront B reach the surface of separation over here, that is, let me call this point C, after a time, say tau. Tau is a Greek alphabet. J തിരിച്ചിടുന്ന പോലാണ് tau എഴുതുന്നത്. Let this point B, wavefront B, reach PP dash or the point C after a time tau. Then I can say that this distance BC is equal to V1 into 2. അതെങ്ങനെ കിട്ടുന്നേ? BC is a distance. V1 is the speed of light in the first medium. We know that speed or velocity is equal to distance by time. So distance is equal to velocity into time. So velocity is V1, time I have told 2. B എന്ന് പറയുന്ന പോയിന്റ് സിയിലെത്താൻ എടുത്ത ടൈമാണ് 2. അതേ സമയം കൊണ്ട് എ എന്ന് പറയുന്ന പോയിന്റ് ഇയിലെത്തുന്നു. ഓക്കെ, the wave from the point A reaches E at the same time 2. B സിയിലെത്തിയ സമയം കൊണ്ട് എ ഇയിലെത്തി. ഇത് നേരെയാണ് വരുന്നത്. ഇത് ഇച്ചിരി വളയുന്നു, ബെൻഡിങ്, rarer to denser. And what about AE? AE distance എത്രയാണ്? I told you speed of light in the second medium is V2. മുമ്പേ ചെയ്ത പോലെ AE എങ്ങനെയാണ് കണ്ടുപിടിക്കുന്നത്? AE is a distance. Distance is equal to speed into time or velocity into time. How much is velocity? v2 into time is 2. So AE is equal to 2. BC is equal to v12 എന്ന് പറഞ്ഞ പോലെ AE is equal to v2 into 2. So I told you BC is equal to v12 and AE is equal to v22. What is tau? The time taken by the wavefront to reach here, and same time this point to reach here. Okay. Now മുമ്പ് ഞാൻ പറഞ്ഞല്ലോ, if this angle is I, this angle is also I എന്ന് പറഞ്ഞല്ലോ. This is our angle of incidence. ഇത് വന്നത് എങ്ങനെയാണെന്ന് മനസ്സിലായോ? This angle is 90 degree, this angle is 90 degree. So how much is this? 90 minus I. ഇതോ 90 90 minus 90 minus I. So you will get again I. അതേപോലെ this angle is R, angle of refraction. If this angle is R, you will get this angle is also R. Same principle. Okay. Now what are we going to derive? We are planning to derive Snell's law. What is Snell's law? According to Snell's law, sin I by sin R is a constant, isn't it? So from the diagram, let us find out what is sin I. Sin I. What is sin I? Look into the diagram carefully. This angle is I. What is sin I? Sin I is equal to opposite side by hypotenuse. From this diagram, what is the opposite side? BC by AC. BC by AC. Opposite side by hypotenuse. Okay. Similarly, find out sin R. This angle is R. So find out sin R opposite side by hypotenuse. AE by AC. Sin R is equal to AE by AC. Now instead of BC we can write V12. Instead of AE we can write V22. So sin I is equal to V12 by AC. Sin R is equal to V22 by AC. So let us find out the refractive index. N is equal to sin I by sin R is equal to V12 by AC by V22 by AC. AC and AC gets cancelled. Let us take the reciprocal and multiply. V12 by AC into AC by V22. We are dividing fractions, taking the reciprocal and multiply. Cancel the like terms. What is remaining? V1 by V2. So we get sin I by sin R is equal to V1 by V2. What is our aim? Our aim is to prove that sin I by sin R is N. To derive the Snell's law. അത് കണ്ടുപിടിക്കാൻ വേണ്ടിയാണ് sin I by sin R is equal to N എന്നാണ് നമുക്ക് കിട്ടേണ്ടത്, പ്രൂവ് ചെയ്യേണ്ടത്. ഓക്കെ. സോ ഇപ്പോൾ നമുക്ക് കിട്ടിയിരിക്കുന്നത് എന്താണ്? sin I by sin R is equal to V1 by V2. Now we know that refractive index, ഒരു മീഡിയത്തിൻ്റെ റിഫ്രാക്റ്റീവ് ഇൻഡെക്സ് എന്ന് പറയുന്നത് ഇറ്റ്സ് എ റേഷ്യോ. Refractive index of a medium is equal to speed of light in vacuum. Speed of light എത്ര? It is represented as c. You have studied in 10th standard c. Speed of light is represented by the letter c. And what is its value? Okay, 3 into 10 raised to 8 meter per second. You have studied that. So refractive index is the ratio of speed of light in vacuum divided by speed of light in the given medium. തന്നിരിക്കുന്ന മീഡിയത്തിലെ സ്പീഡ് എത്രയാണ്? നമ്മൾ ഫസ്റ്റ് മീഡിയത്തിൽ എടുത്ത സ്പീഡ് എത്രയാണെന്നാ? ലെറ്റ് ഇറ്റ് ബി V1 എന്നാണ് എടുത്തത്. സോ റിഫ്രാക്റ്റീവ് ഇൻഡെക്സ് ഓഫ് ദ ഫസ്റ്റ് മീഡിയം ഇസ് ഗിവൺ ബൈ N1 is equal to speed of light in vacuum by speed of light in the medium V1. അതേപോലെ സെക്കൻഡ് മീഡിയം ഡെൻസർ മീഡിയത്തിൻ്റെ റിഫ്രാക്റ്റീവ് ഇൻഡെക്സ് N2 is equal to ഇതേപോലെ തന്നെ C by V2. Okay. So we have already got that sin I by sin r is equal to v1 by v2. ഈ v1 നെ v2 നെ നമ്മൾ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാൻ പോവാം. So from this equation, what is the value of v1? From the first equation, v1 is equal to v1 ഇവിടെ ചെല്ലുമ്പോൾ c by n1, isn't it? അതേപോലെ what is the value of v2? v2 is equal to c by n2. So let us call this as equation 1. Equation 1 ൽ ഒന്ന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് നോക്കാം. The values of v1 and v2. What is sin I by sin r? Sin I by sin r is equal to, instead of v1 and v2, we can write what is the value of v1? c by n1. Divide by what is the value of v2? c by n2. Let us take the reciprocal and multiply. Is equal to c by n1 into n2 by c. C and c get cancelled. What is remaining? n2 by n1. We have already studied what is n2 by n1 is equal to n21, refractive index of the second medium with respect to first medium. So we have proved that sin I by sin r is equal to n21. So thus we get our Snell's law. Sin I by sin r is equal to n21. So we have derived sin I by sin r is equal to n21. അതായത് Snell's law we have derived using wave theory.